Hey Geometry, we're continuing on in our new unit. Today we're going to talk about making scale drawings using the ratio method. First of all, based on what you may recall from grade 8, which would have been Algebra 1, describe what a dilation is. Goodness, we can talk about a dilation as a reduction, that's an I, or enlargement of any figure where all of the side lengths are proportional to the original figure and the angles stay congruent to the original figure. So let's talk about lesson 1 for a minute. I know we're in lesson 2, but in lesson 1 we reviewed the properties of a scale drawing and we created scale drawings of triangles using compasses and protractors. What we learned was as long as our scale drawings had angles that were equal in measure to the corresponding angles of the original figure, and that if the lengths were a constant proportion to the corresponding lengths of the original figure, the location and orientation of our scale drawing did not concern us. It didn't matter which way it was rotated, how it looked, as long as the side lengths were proportional and the angles were equal in measure. They were congruent. So today we're going to use a systematic process of creating a scale drawing called the ratio method. The ratio method dilates the vertices. Just go something basic. So it dilates the vertices of the provided polygon figure, in this case a triangle. The details that we remember from our opening exercises, the enlargement and the reduction, are characteristics that are consistent with scale drawings. We're going to verify that the resulting image created by dilating, these vertices aren't going to change in our scale drawing. Okay, if we talk about a dilation, it would be a dilation over the factor r. This would be a dilation with a factor of r. What we're really doing is taking the length, the distance between 2 points, or the length of a segment, and if we had that length, we're just multiplying that by r. Okay, so if the length of OP was 2 inches, we're just multiplying that by, r, and we would get 2r, okay, whatever that dilation is. And it's going to, if r is greater than 0, it's going to make your segments longer. Go down here, we have O and P. If r is less than 1, okay, if it's a fraction, then we're actually going to reduce the length of our figure. Okay, the original, and then we are dilating it into a reduction. All right? So first of all, it says create a scale drawing of the figure below using the ratio method about center 0 and scale factor r equals 1/2. So here we're going to think to ourselves, are we reducing or enlarging something? When we have a scale factor of less than 1, our new figure is going to be smaller. So I already know it's going to be smaller. So we have our steps here. Step 1, draw a ray beginning at 0, which I didn't include 0. Let's see. O, not 0, the origin. It's over here somewhere. So draw a ray beginning at O through each vertex of the original figure. Done. Dilate each vertex along the appropriate ray by a scale factor of 1/2. It's going to get smaller. So I used a ruler And I actually used a little straight edge with centimeters on it because it was easier for me to read. So use a ruler to find the midpoint between O and D, and then each of the other vertices. So I found D prime, C prime, B prime, A prime, and E prime. I just measured the length of this ray and divided by 2. And I've got my new figure. So I joined the vertices in the way they are joined in the original figure. And it looks the same. Looks pretty good. Okay, here, just like lesson 1, I do not need you to draw all of these in your classwork. We are going to get practice doing these in your problem sets. I just need you to know how to. This isn't like an algebra where I need you to practice a few on your own to make sure you understand. We're just drawing rays and just getting new points, our original points and our dilated points. Okay, so here's an exercise, same type of problem. Create a scaled drawing of the figure below using the ratio method about center O and scale factor of 3/4. So we're still getting smaller, just not quite as small. Verify the resulting figure is in fact a scale drawing by showing that corresponding side lengths are in constant proportion and corresponding angles are in equal measurement. So I drew rays. Okay, I took my straight edge. I measured from O to A, and then I multiplied by 3/4 and got my new A. Did that for each of the points, and then I was able to connect the dots. Now to verify, for each one of these, I measured from O to A. I got the length of that segment, and then I took that length of segment and I multiplied by 3/4. And I did that for each of them. Oh, and that gave me the length of O, A prime. Okay, did that for OB, got the measurement, multiplied it by 3/4, and that gave me OB prime, etc. So I know my proportions are correct because I calculated them that way. All right, the angle measurements, you can take a protractor and extend the lines a little bit and measure that, angle E looks to be about 90 degrees, so angle E prime should hold that angle at 90 degrees. Okay, the measure of angle B was 45 degrees when I measured it, so the measure of angle B prime should also be 45 degrees. Okay, our angle measures don't change when we scale a drawing. Okay, next one. Create a scale drawing of the figure below using ratio method about center O and a scale factor of 3. My scale factor is greater than 1, so my drawing is going to get bigger. So step 1, draw a ray beginning at O through each vertex. Okay, I went through B, D, C, and A. I knew it was going to be bigger, so I tried to make the rays long enough. Use your ruler to determine the location of A prime. So I measured from O to A, and then I multiplied that times 3 and got how long O to A prime was going to be. All right, did the same thing for B, D, and C. And then draw the corresponding line segments, and I labeled them. Part B says locate a point X so that it lies between A and B. So I measured A and B, divided it in half, and got point X. And then I went ahead and measured between A and X, right here. You see my rough measurements. Then I went ahead and took that measurement and multiplied it by 3 and got a new measurement. So I measured from A prime and found where X prime should be. Then I double checked. Like if I drew a ray right through there, it hit both X and X prime, and it should. It should definitely hit both X and X prime. The next question. Let's just talk about it. Does A prime, B prime, C prime, D prime look like a scale drawing of A, B, C, D? It does. Can we verify it? We could verify it by measuring all the segments and by measuring the angles. Okay, the angles are going to be consistent, and the lengths of the sides are going to be proportional. Let's look at this next question. Imagine a dilation of the same figure in parts A and B. What if the ray from the center, what if the ray from the center passed through two distinct points, such as B and D? goodness. It's really saying, what if, let me get a thicker pen. Maybe. Oh, there it was. What if I drew from DB straight down? Okay, that just means that both B prime and D prime would lie on the same line. If B and D are on the same line, then B prime and D prime would also be on the same line. All right, so triangle A prime, B prime, C prime is a scale drawing of triangle ABC, drawn by using a ratio method. Use your ruler to determine the location of center O used for the scale drawing. So I took my ruler, I just drew a line through here, a line through here. They met, I was pretty sure I knew where O was, but then I just verified. Okay, where all three of them meet is where your location of the center is. Next, use the figure with center O and a scale factor of 5/2. Okay, so we have 2.5 to create a scale drawing. Verify the resulting figure is in fact a scale drawing by showing the corresponding side lengths are constant proportion, etc., etc. So I did the same thing with the other ones, drew a ray through all of the vertices of this polygon, and then I measured from 0 to E, and I multiplied it by 2.5 and got E prime. Okay, repeat for A prime, D prime, B prime, and C prime. Went ahead and connected all of the new vertices in the same order, and I got the new shape. Okay, to verify, we're basically saying that the length from O to E is given. I multiplied that by 2.5 and got my new measurement. Excuse me. I did that for all the same. Whatever I got times 2.5, and that gave me my new measurement. If I took my protractor and measured all of my angles, I know that the measure of angle A is approximately 94 degrees, so the measure of angle A prime should hold that angle measurement. We should have the same degrees. Okay, and that's true for all of them. Okay, the measure of angle B was a little bit bigger. It was 118 degrees, so the measure of angle B prime is also going to be 118 degrees. Cool? All right, summarize the steps to create a scale drawing by the ratio method. Be sure to describe all necessary parameters to use the ratio method. Okay, I'm going to push pause and go ahead and type this in so you can actually read it. Okay, to summarize this, to use the ratio method to create, I guess I should have proofread it before I pushed go. Create, if you can read that, you can't, there we go. A scale drawing, the problem must provide a polygonal figure, a center 0, and a scale factor. To begin the ratio method, draw a ray that originates at O and passes through each vertex of the figure. We are dilating each vertex along its respective ray. Measure the distance between O and a vertex and multiply it by the scale factor. The resulting value is the distance away from O at which the scaled point will be located. Once all the vertices are dilated, they should be joined in the same way as they are joined in the original figure. Awesomeness. All right, let's get into a fun problem rather than just drawing stuff. Okay, a clothing company wants to print the face of the Statue of Liberty on a t-shirt. The length of the face from the top of the forehead to the chin is 17 feet. The width of the face is 10 feet. Okay, we have 17 feet and 10 feet. Given that a medium-sized t-shirt has a length of, let's see if I can draw t-shirts. That's not too bad. So the length of a medium-sized t-shirt has a length of 29 inches and a width of 20. So here we have 29 inches and 20 inches. What dimensions of the face are needed to produce a scaled version that will fit on the t-shirt? What would you use to model the face of the statue? It depends. I probably wouldn't do a circle because we don't have vertices. That would be a bad idea. I think maybe a rectangle may be a better thing to model the face of the shadow of the statue. I mean, if you wanted to pick a triangle, okay, an oval, I just don't think that would be a good idea because we just don't have vertices. Right, knowing that the maximum width of the t-shirt is 20 inches, what scale factor is needed to make the width of the face fit on the shirt? Let's see. We're at 20 inches. And that's for the face. We're at 10 feet for the actual statue. So 10 feet times 12 inches in a foot, that would give us 120 inches for the actual statue. Okay, this shouldn't be face. This would be 20 inches for the shirt. So the scale factor, I think it would be safe to say, is 20 over 120. And if I reduced that, it would just be 1/6. The width of the face on the t-shirt will need to be scaled to 1/6 the size of the statue's face. What scale factor should be used to scale the length of the face? I would use the same scale factor or it'll be skewed, right? We need to keep everything proportional, so if we use the same scale factor, then, if we're shrinking this part of the statue in the same proportion as we're shrinking that part of the statue, it'll look a lot better. So, using the scale factor that we talked about, what is the scaled length of the face? So if we're at 17 feet, if I multiply that by 12 inches in a foot, that gives me 204 inches. I'm going to multiply that by my scale factor, and I'm down to 34 inches. The scaled length of the face would be 34 inches. The length of the shirt is only 29 inches, so the face isn't going to fit, right? So let's identify the scale factor we would use to ensure that the face of the statue was in proportion and it'll fit on the t-shirt. So a scale factor of 1/6 didn't work. If we scaled by 1/7, okay, that gives us 29 inches. Not quite good. Let's try 1/8. Oops. I don't have my good pen with me today, so I'm struggling. That gives me 25.5 inches. I think that'll work. So it looks like a scale factor of 1/8 would give us, this is inches, and 15 inches would be our width, and our length would be 25.5. So that's definitely going to work. All right, the t-shirt company wants a width of the face to be no smaller than 10 inches. What scale factors would be used to create a scaled version of the face that meets this requirement? Just going to be some trial and error here. So let's look. What is our width? Would have had it 120 inches for our width because it was 10 feet. If I scaled it by 1/8, doing some math here. Yep, that would work. 1/9 would work. A 1/10 would still work. An 11th. Yep, that'll work. And let me check a 12th real quick. I'm at 120 times, or divided by 12, which is 10. Yep, these scale factors all work for those requirements. The t-shirt company wants the width of the, oh, we just did this one. That's funny. If it costs the company 0.005 cents for each square inch of print on a shirt, what are the maximum and minimum costs for printing the face and the Statue of Liberty on one t-shirt. We've got dimensions area, right? We did 15 times 25.5. Do math here, 15 times 25.5. That gives me 382.5 times 0.005. That gives me $1.91 per shirt. The small scale factor, that was the 1/12. That gives me 10, and then 204 divided by 12 is 17. 10 times 17 times 0.005 is 85 cents. Cool. Good things to know. All right. Read through this. We're not going to do it today. I'm going to save this for a project for us to work on later.